All right, today we're going to pull back the curtain on one of the most powerful tools in all of AI, machine learning classifiers. In short, these are the algorithms that teach computers a pretty incredible skill, how to sort the world around us. And believe me, you see them in action every single day.
I mean, seriously, every single day you see this. You ever wonder how your email inbox just knows what's junk and what's actually important? That simple daily decision, spam or not spam, that's a perfect example of a machine learning classifier hard at work. It's all about teaching a computer how to sort things, a task that's, super simple for us, but it's a genuine marvel of engineering for a machine.
So let's get right to the heart of it. What is machine learning classification? Well, at its most basic level, it's really about one thing: teaching a computer how to sort data into these predefined groups, or what we in the biz call classes. Let's take a quick look at the more formal definition.
Okay, let's break that down. The key idea here is training. We show the machine a ton of examples that we've already labeled. This one's spam, this one isn't. And after seeing enough of those, the machine starts to recognize the patterns on its own. So then, when a new, totally unseen piece of data comes along, it can make a really good educated guess about which bucket it belongs in.
Here's a great way to think about it. Imagine you're a wine expert and you're training an apprentice. You show them hundreds of bottles, each with different features like acidity and color, and you tell them which type each one is: type A, type B, type C, and so on. Well, the classifier, that's your apprentice. Its whole job is to look at a brand new bottle and, based on everything it's learned, correctly figure out what type it is.
And this is not just some abstract academic exercise. This technology is quietly humming away in the background of our lives. It's not just filtering spam. It's helping banks decide on credit approvals. It's assisting doctors with medical diagnoses. And yeah, it's even powering those targeted ads you see online. It is everywhere.
Okay, so if classification is the job, what are the tools? Well, it turns out there isn't just one way to sort data. Not at all. Data scientists have this whole toolbox of different algorithms to choose from. So I think it's about time we meet the classifiers themselves. Think of classifiers as the engines that drive this whole process. They're the actual algorithms, the sets of rules and mathematical procedures that do all the heavy lifting. They're the things that take in all that training data and learn how to make smart predictions on new information they've never seen before.
And let me tell you, this machine learning toolbox is packed with options. We've got simpler methods like logistic regression and more complex tools like decision trees, which kind of work like a big flowchart of if-then questions. We've got support vector machines, and we go all the way up to the real powerhouses of deep learning like neural networks. The main thing to remember is that each one of these tools approaches the problem of sorting in its own unique way.
Now, not all sorting jobs are the same. One of the very first questions you have to ask is, how many piles are we sorting into? This brings us to a really fundamental distinction in the world of classification: binary versus multi-class.
Binary classification is basically a yes or no question. Is this email spam or not? Is this transaction fraudulent or not? There are only two possible outcomes. Algorithms like linear classifiers and SVMs are naturally built for this kind of thing. But multi-class classification, that's our wine problem. You're choosing from more than two options. Is it type A, or B, or C, or D, or E? And algorithms like random forests are designed to handle that complexity right out of the box.
And this leads to a really clever problem-solving moment in machine learning. What happens when you have a fantastic algorithm that's only designed for two categories, but your problem has 5 or 10 or even 100 categories? Do you just throw that tool away? No way.
You get creative. The first strategy is called one versus all, or OVA for short. For our 5 wine problem, you'd train 5 separate binary classifiers. The first one only learns to answer one question: is this wine A or is it something else? The second one learns, is this wine B or something else? And you do that for all 5. Then when a new wine comes in, you show it to all 5 classifiers, and whichever one yells the loudest, whichever one gives the highest confidence score, gets to label it. Pretty clever, right?
Now, the second approach is even more focused. It's called one versus one, or OVO. So instead of comparing one class against all the others, this technique trains a special, dedicated classifier for every single head-to-head matchup between the classes.
And this is where the strategy just explodes in complexity. For a problem with, say, 20 different classes, that one versus all method we just talked about needs, 20 classifiers. Makes sense. But with one versus one, you would need a staggering 190 different classifiers
just to cover every single possible pairing.
So why on earth would anyone use a method that needs so many more classifiers? Well, it's a classic trade-off. While OVO needs way more models, each individual classifier has a much easier job to do. I mean, instead of learning some complex rule to separate one class from 19 others, it only has to learn a simple rule to separate two. And that smaller, more focused training data often has less noise, making it easier for the algorithm to find a clean dividing line. And sometimes that can actually lead to better overall performance.
So far, we've kind of been assuming that every item gets exactly one label. It's either spam or not spam. It's wine A or B or C. But come on, the real world is often way messier than that. And this brings us to another important flavor of this technology, multi-label classification.
And just like the name suggests, multi-label classification completely breaks that one-choice-only rule. It's the task where a single data point can be assigned several labels, all at the same time. It's not about picking one from a list, it's about picking all of them that apply.
This comparison makes the difference totally clear. A multi-class model looking at a photo will be forced to choose one. Is it a cat, a dog, or a bird? It's like a multiple choice question where only one answer is right. But a multi-label model, it asks a series of true or false questions. Is there a cat in this photo? Yes. Is there a dog? Yes. Is there a bird? No. So it can apply both the cat and dog labels to the exact same image.
Okay, let's finish up by zooming in on one of the most fundamental tools we saw in that toolbox. It's often one of the very first classifiers people learn, because its core idea is just, well, it's beautifully simple. So, what exactly is a linear classifier? Imagine your two classes of data are just plotted as dots on a piece of paper. A linear classifier does exactly what it sounds like. It draws one single straight line to separate the two groups. That's it. It's that simple. If you're in 3 dimensions, that line becomes a flat plane. It's really the most direct way possible to divide a space in two.
And hey, don't mistake that simplicity for weakness. Linear classifiers are incredibly useful. For one, they are blazing fast, which is absolutely critical in a lot of applications. They also tend to work surprisingly well on data that's very sparse, which just means it has a lot of zero values, or when you're dealing with problems that have a massive number of features or dimensions.
So after looking at all these different types and strategies, what's the big takeaway here? It's that everything we've talked about, binary, multi-class, multi-label, that whole toolbox of algorithms, it all boils down to one fundamental skill: teaching a machine how to intelligently sort information into the right buckets that we've defined for it.
And these tools, they're just getting more accurate and more powerful every single day. They've already moved from sorting our email to helping with huge financial decisions and even life-or-death medical diagnoses, which, leaves us with a final, pretty important question to think about. As these classifiers keep getting better and better, what truly human decisions will we be willing to trust them with next?
So where's this from? It's all coming from the channel Learn with Praveen.